All right, let's talk about something that makes most IT pros sweat, IP subnetting. It's one of those topics that just seems impossible at first. But what if I told you there's a simple trick, a little secret, that can take all that painful binary math and let you solve these problems in, like, seconds? Well, that's exactly what we're going to do today.
Yeah, this quote right here, it hits the nail on the head, doesn't it? If you've ever tried to learn subnetting the old school way, you know this feeling. Your head starts spinning, the numbers all blur together, it's totally normal. But trust me, we're about to put a stop to all that.
Look, there's no way around it. Subnetting is absolutely fundamental if you want to work with computer networks. It's how we keep everything organized, efficient, and secure. But the way it's usually taught, oh man, it's all about converting to binary, and it is just a massive headache.
When you boil it all down, the idea is super simple. All we're doing is taking one giant network and slicing it up into smaller, more useful little networks, or subnets. That's it. The concept is easy, but it's the how that always trips people up.
So the traditional method makes you take a long IP address, turn the whole thing into a string of ones and zeros, do a bunch of weird math. It's just slow and super easy to mess up. There is a much, much better way, and we're not touching binary today, I promise.
So instead of all that nonsense, we're going to take a shortcut. We're going to use a simple little chart, you can call it a cheat sheet, that thousands of people have used to fly through their certification exams and nail their job interviews. It's a total game changer.
We're calling it the Subnetting Secret Chart. Seriously, think of this as your secret weapon. The best part? After we're done here, you'll be able to scribble this thing down from memory in less than 30 seconds anytime you need it.
This quote is a promise, and I'm telling you, we're going to make good on it. So forget about the weeks and weeks of frustration you thought you had ahead of you. We're going to crack this thing in the next few minutes.
Okay, time to actually build this thing. I'm serious. Grab a piece of paper, a pen, a napkin, whatever you've got, because we're going to build this chart together, step by step, and you'll see just how easy it is.
It really just comes down to two main steps to get the core chart built. That third step, the design columns, that's for some more advanced stuff, so we're going to ignore that for now. We just need the first two. You ready? Let's do it.
All right, step one, the top row. This is so easy. All you do is write the number 1 way over on the right side of your paper. Then you just double it as you move to the left. So 1 becomes 2, then 4, 8, 16, 32, 64, and finally 128. And boom, top row is done. See? Easy.
Okay, now for the column on the left. This part looks tricky, but it's not. You just add numbers together. Start with the first number from your top row, 128. Write that down. For the next number, you take that 128 and add the next number from the top row, which is 64. So 128 plus 64 is 192. Then you take 192 and add the next one, 32, which gets you 224. And you just keep doing that all the way down. That's it. The whole chart is built.
Okay, chart's built. Now for the fun part. Let's see this thing in action. We're going to throw a real exam-style question at it and watch how fast we can get the answer.
Here we go. Problem number 1. We've got an IP address, and then we have this /26 thing at the end. That's just CIDR notation. All it does is tell us how big the subnet mask is. The only part of that we really care about right now is the number itself, 26.
So an IP address that starts with 192 is what we call a Class C network. By default, those always have a /24 subnet mask. Ours is a /26. So what's the difference between 26 and 24? It's 2, right? That number, 2, is our magic number. It means we've borrowed 2 bits. So on our chart, we just count 2 spots over from the left on the top row and 2 spots down on the left column.
And bam, the chart literally just tells you the answer. Look where our second tick landed on the top row. The number 64. That's our increment. It tells us how big the subnets are. And our second tick on the left column landed on 192. That's the last number in our subnet mask. So now we just count up in chunks of 64. The first subnet of 0, the next is 64, the next is 128. Our host is 100, so where does it fit? Right inside the 192.168.1.64 subnet. Problem solved. No binary, nothing.
I know what you're thinking. That was way too easy. So let's try a trickier one. This is a Class B address. It looks a little scarier, but I'm telling you, the method is exactly the same.
Okay, so this IP starts with 172, which means it's a Class B network. And Class B networks have a default mask of /16. Ours is a /19. So what's 19 minus 16? It's 3. That's our magic number this time. So what do? We count 3 ticks across the top row and 3 ticks down the left column. That's it.
And again, the chart just hands us the answers. Our third tick on top is on the number 32, that's our increment. The third tick on the left is on 224, that's our subnet mask value. Now here's the only difference. Since this is a Class B network, all the action happens in the third part of the IP address. So we count up by 32 in that third spot. 172.16.0.0, then 32.0, then 64.0, then 96.0. Hey, wait, our host is 102.1.1. That fits right into the 172.16.96.0 subnet. Done. Again, in second.
And honestly, that's the whole trick. That's the secret. What starts out at a little chart you have to draw on paper, after you do it just a few times, becomes something you can just see in your head. It goes from a neat trick to just a habit. Subnetting stops being this giant, scary monster, and it becomes just another tool you know how to use.
It's kind of crazy when you think about it, right? We just took this really complex digital problem that gives people fits, and we solved it with a dead simple chart you could draw in the sand. It makes you wonder, what other impossible problems out there are just waiting for someone to come up with a simple, elegant chart to solve them? Something to chew on. Thanks for hanging out with me.